You think the moon floats. You think it hangs there, suspended in the heavens, held aloft by some invisible scaffolding that keeps it from crashing into us. You have never asked the obvious question. Why does it not fall? Everything falls. Drop a stone, it falls. Drop a hammer, it falls. Drop anything at all from any height, and it plummets toward the earth with absolute certainty. Yet you look up at night and see that pale disk sailing through the darkness, and you simply accept that it stays there. You never demanded an explanation. You never felt the strangeness of it. That acceptance, that passive tolerance of mystery, is precisely why you have misunderstood the moon your entire life. Let me tell you what is actually happening 240,000 miles above your head. The moon is falling. Right now. This very second. It has been falling for 4.5 billion years. It will continue falling long after you and everyone you know has turned to dust. The moon is not suspended. The moon is not held up. The moon is plummeting toward the earth at this exact moment, and it has never once stopped falling since the day it formed. That should disturb you. That should make you sit forward and demand to know how something can fall for billions of years without ever hitting the ground. And I am going to show you. I am going to show you how I figured this out 3 centuries ago with nothing but mathematics and an apple and a question that nobody else thought to ask. But first, you need to understand something about falling itself. You think you understand it? You do not. When I was a young man at Woolsthorpe, watching that apple drop from the tree, I did not have some mystical vision. I did not suddenly comprehend the universe in a flash of divine inspiration. What I had was a question. A simple, irritating, relentless question that would not leave me alone. The apple fell. Fine. Everyone knows apples fall. But how far does the pull extend? Does the earth's pull stop at the treetops? Does it fade at the height of mountains? Does it reach the clouds? And if it reaches the clouds, does it reach higher still? Does it reach the moon? That question changed everything. Not because it was brilliant, because it was obvious. Painfully obvious. So obvious that the greatest minds before me somehow failed to ask it. They separated the heavens from the earth. They put celestial bodies in a different category, governed by different rules, untouched by the crude forces that make apples fall and stones sink and rain descend. I refuse to accept that division. I ask the stupid question, what if there is no division? What if the same force that pulls an apple toward the ground also pulls the moon? And if it does pull the moon, then why has the moon not already smashed into us? Here is where most people fail. Here is where you have probably failed your entire life without realizing it. You assume that if something is being pulled, it must be getting closer. You assume that falling means approaching. You picture the moon being tugged toward Earth, and you cannot understand why it does not arrive. But think about what falling actually means. Think carefully. When you drop a stone, it accelerates downward. It gains speed as it descends. The stone does not simply move toward the earth. The stone is being constantly accelerated toward the earth. Every fraction of a second, its velocity increases. That acceleration is what we call falling. Falling is not a position. Falling is not even a movement. Falling is a change in movement. Falling is acceleration toward ascent. Now here is the part that should break your brain. The moon is accelerating toward the earth right now, constantly, without pause. Every single second, the moon's velocity is being bent toward our planet. The moon is falling in the precise technical sense that a dropped stone is falling. The only difference, the only reason it does not crash into us, is that the moon is also moving sideways, very fast, incredibly fast. Fast enough that by the time it has fallen a little bit closer, it has also moved far enough sideways that the Earth is no longer directly beneath it. The ground keeps curving away. The moon keeps falling toward where the Earth was, but the Earth has curved out from under it. So the moon falls and falls and falls and never lands because the target keeps moving. Do you see it now? The moon is not floating. The moon is perpetually plummeting and perpetually missing. Orbit is not suspension. Orbit is an endless fall that never reaches the ground. Let me make this concrete. Let me give you numbers so you can feel how real this is. In 1 second, the moon falls toward the Earth by about 1.4 millimeters. That is all. 1.4 millimeters, the width of a small seed. In that same second, the moon moves sideways by about 1 kilometer, 1,000 meters to the side, while dropping 1.4 millimeters downward. The downward fall is constantly happening, constantly bending the moon's path, constantly curving its trajectory into that great circle we see from Earth. But the sideways motion is so enormous compared to the tiny downward deflection that the moon sails past us over and over, forever falling, forever missing. 1.4 millimeters per second. That is the rate at which the moon falls. Every second. For billions of years. And you never knew. You looked up at the sky and saw something stationary, something fixed, something hanging in place. What you actually saw was the universe's longest continuous fall, a descent that began before life existed on Earth and will continue until the sun swells and swallows everything we know. Now, I need you to understand how I calculated this, because the calculation itself reveals something even more profound, something that would unlock an avalanche of discoveries that have not stopped cascading through science for 300 years. My question was simple. If the Earth's pull reaches the moon, how strong is it up there? I already knew how strong it was at the Earth's surface. I could measure that with falling objects. A stone dropped near the ground accelerates at about 32 feet per second, roughly 10 meters per second, if you prefer that measure. Every second, a falling object gains 10 meters per second of speed. That is the strength of the pull at Earth's surface. But the moon is far away. The moon sits at roughly 60 Earth radii from the center of our planet, 60 times further from Earth's center than we are standing on the surface. If the force weakens with distance, and I was certain it must, then how much weaker is it at the moon's distance? Here is where I made my leap. I proposed that the force does not merely decrease with distance, it decreases with the square of the distance. Double your distance from Earth's center, and the force falls to 1/4. Triple your distance, and the force falls to 1/9. Move 60 times further away, as the moon is, and the force drops to 1/60 squared, 1/3600. The pull that accelerates a stone at 10 meters per second at Earth's surface would accelerate the moon at 10 divided by 3,600 meters per second. That comes out to about 0.0027 meters per second, 2.7 millimeters per second. Every second, the moon's velocity bends toward Earth by about 2.7 millimeters per second. And in 1 second of that bending, moving at its orbital speed, the moon is deflected downward by roughly 1.4 millimeters. The geometry works out. The numbers align. The same force that drops apples also curves the moon's path. The same mathematics describes both. There is no division between heaven and earth. There is only one force, weakening with distance, reaching across 240,000 miles of void to tug on that pale wanderer and keep it forever circling, forever falling, forever missing. Do you see what I discovered? I did not discover that things fall. Everyone knew that. I did not discover that the moon orbits Earth. Everyone knew that too. What I discovered was that these two facts are the same fact. The falling of an apple and the orbiting of the moon are identical phenomena operating at different scales. The moon is just an apple that was thrown sideways, hard enough to keep missing the ground. And that realization, that single insight, began an avalanche. Because if the moon orbits Earth by falling, then Earth must orbit the sun by falling, and the other planets must orbit the sun by falling, and the moons of Jupiter must orbit Jupiter by falling, and every motion in the heavens, every orbit, every trajectory, every comet streaking past, every asteroid tumbling through the void, all of it is falling. The entire universe is in free fall. Nothing floats. Nothing hangs. Nothing is suspended by invisible threads. Everything is falling toward everything else. And the only reason it all does not collapse into a single point is that everything is also moving sideways. The universe is a symphony of endless falls that perpetually miss their targets. That is gravity. That is what I found beneath the apple tree. Not a simple observation about fruit dropping from branches, but a key that unlocks the mechanics of everything from pebbles to planets. Let me make sure you feel the strangeness of this. Before my work, people thought of the heavens and the earth as fundamentally different realms. The celestial was eternal, perfect, unchanging. The terrestrial was temporary, corrupt, subject to decay. The moon belonged to the heavens. Apples belonged to the earth. The idea that the same force, the same mathematics, the same physics could govern both was revolutionary. It was offensive to many. It meant that there was nothing special about the heavens. It meant that the moon was just a rock subject to the same crude forces that make mud splatter and trees fall. I unified the cosmos by degrading the celestial to the terrestrial, or, if you prefer, by elevating the terrestrial to the cosmic. Either way, I erased a boundary that humans had assumed for millennia. There is no up there and down here. There is only here, everywhere, all operating under identical laws. But I'm getting ahead of myself. You need to feel this more deeply before we proceed. Let me give you a thought experiment. Imagine you are standing on a very tall mountain, impossibly tall, so tall that you are above the atmosphere, above the air resistance that would slow things down. You have a cannon. You load the cannon and fire it horizontally, parallel to the ground. The cannonball flies forward and begins to fall. It curves downward and eventually hits the ground some distance away. Straight forward. Now you load the cannon again and add more powder. You fire it harder. The cannonball flies faster, covers more horizontal distance, but still falls and hits the ground. The arc is longer, but it still ends in impact. You keep adding powder. You keep firing faster. Each time, the cannonball travels further before landing. But here is the thing about Earth. Earth is round. The surface curves away beneath the cannonball as it flies. If you fire the cannonball fast enough, something remarkable happens. The cannonball falls toward the Earth, but the Earth's surface curves away beneath it at exactly the same rate. The cannonball keeps falling, but the ground keeps dropping away. The cannonball never lands. It just keeps falling around the Earth. Forever. You have put the cannonball into orbit. You have created a tiny metal moon, and all you did was throw something sideways fast enough that its endless fall curves at the same rate as the planet beneath it. This is not metaphor. This is not analogy. This is literally what orbit is. Every satellite circling Earth right now is just a very fast cannonball that is perpetually falling and perpetually missing. Every astronaut floating in the space station is falling toward Earth at this exact moment. They feel weightless, not because there is no gravity, but because they and everything around them are falling together. They are in freefall, constant, continuous, endless freefall. The space station does not hover 300 kilometers up. It plunges toward Earth every second of every day. But it moves sideways at 28,000 kilometers per hour, fast enough that its fall curves around the planet instead of ending on the surface. This is not floating. This is falling with style. This is falling so gracefully that you loop around and keep falling forever. Now think about the moon again, with this picture in your mind. The moon moves sideways at roughly 1 kilometer per second. Every second, it travels 1,000 meters along its orbital path, and every second, gravity bends. Its motion curves its trajectory, deflects it 1.4 millimeters closer to Earth than a straight line would carry it. 1.4 millimeters. That deflection does not feel like much. That is because you are not thinking about what happens when you compound that deflection over time. Over a month, those tiny bends add up. They curve the moon's path into a complete circle, or nearly complete. The moon's orbit is slightly elliptical, but the principle holds. The continuous accumulation of tiny falls produces the smooth, graceful arc that carries the moon around Earth every 27.3 days. And the moon never notices it is falling. If you could stand on the lunar surface, you would feel no sensation of plummeting. You would see Earth hanging in your sky, seemingly motionless, and you would have no intuitive sense that you are constantly accelerating toward it. But you are. The mathematics is unambiguous. The geometry is clear. You are falling. You have always been falling. You will never stop falling. I need you to hold two ideas in your head simultaneously. First, the moon is moving sideways very fast. Second, the moon is constantly being pulled downward toward Earth. These two motions combine to produce orbital motion. If you remove the sideways motion, the moon would fall straight down and crash into Earth in about 4.5 days. If you remove the gravitational pull, the moon would fly off in a straight line, escaping into the void, never to return. Orbit exists only because both components are present. The sideways motion tries to carry the moon away in a straight line. Gravity bends that line into a curve. The balance between these two produces a closed loop, a persistent path, an eternal fall. And here is the profound part. The moon does not know it is in orbit. From the moon's perspective, it is simply moving through space. It has no sense of circling anything. Orbits are only visible from outside. When you look up at the moon, you see the shape of its path. The moon itself experiences only motion through emptiness, unaware that it is tracing a great circle around a planet that keeps bending its course with invisible fingers. Let me tell you about the avalanche that followed my insight. Once I established that gravity weakens with the square of distance, I could calculate the motions of everything. I could explain why planets closer to the sun orbit faster than planets further out. I could predict the paths of comets. I could account for the tides, those mysterious risings and fallings of the sea that had puzzled humanity for millennia. The same moon that orbits by falling also pulls on Earth's oceans as it passes. The water bulges toward the moon, creating high tides. And because Earth rotates beneath this bulge, different coastlines experience high and low tides as they spin through the regions of raised and lowered water. One force explains both phenomena. One equation captures falling apples and orbiting moons and ocean tides and the paths of wandering planets. That is the power of what I've found. Not a collection of separate rules for separate situations, but a single principle that cascades through every scale, from the smallest pebble to the largest star. But I have not yet told you the strangest part. The part that I myself found deeply troubling. The part that I never fully explained, and that would take 2 more centuries to properly understand. How does the Earth pull on the moon across 240,000 miles of empty void? There is nothing between them. No rope, no chain, no physical connection of any kind. Yet somehow the moon feels Earth's pull instantly, constantly, without any apparent mechanism. I calculated the effects. I described the mathematics. I predicted the motions with extraordinary precision. But I could not tell you how gravity actually works. How does the Earth reach across empty space and tug on distant objects? I call this action at a distance, and I confess that I had no explanation for it. The mathematics worked, the predictions were accurate, but the underlying mechanism remained hidden. I knew that gravity obeyed an inverse square law. I knew it acted between all masses. I knew it explained both terrestrial and celestial motion, but I did not know what gravity was, only what it did. This mystery would haunt physics for 200 years, and when the answer finally came, it would trigger another avalanche, even more profound than my own. A man named Einstein would reveal that gravity is not a force reaching across space. Gravity is the shape of space itself. Mass bends the fabric of space-time, and objects moving through that bent fabric follow curved paths. The moon does not feel a force pulling it toward Earth. The moon travels in a straight line through curved space-time, and that curved path happens to circle Earth. The moon is falling because the space around Earth is warped, funneled inward, shaped like a bowl that everything rolls around. But that is a story for another time. For now, what matters is this. My mathematics works. My predictions are accurate. The moon falls 1.4 millimeters per second, and that fall traces out an orbit. And that orbit arises from the same force that drops apples and raises tides and holds planets in their courses. The mechanism may be stranger than I imagined, but the mathematics stands. 3 centuries of science have only confirmed what I calculated in that Woolsthorpe garden. Let me make sure you truly grasp the geometry here, because this is where most people get confused. They hear that the moon is falling and they picture it spiraling inward, getting closer and closer until it eventually crashes. But that is not what happens. That would only happen if the moon were falling without any sideways motion, or if something were slowing the moon down, removing energy from its orbit, causing it to gradually descend. In the absence of such interference, the moon's orbit is stable. The moon falls toward where the Earth is, but by the time that fall would bring it closer, the moon has moved sideways to a new position, and Earth has rotated beneath it, and the geometry resets. The fall is real. The acceleration toward Earth is constant, but the trajectory remains closed. The moon ends up at the same distance it started, having traced a complete circle, ready to repeat the process forever. Falling does not mean approaching. Falling means accelerating toward, and you can accelerate toward something forever without ever getting closer. As long as you are also moving perpendicular to that acceleration, fast enough to curve around instead of plunging in. Think about swinging a ball on a string around your head. The string pulls the ball toward your hand constantly. The ball is always being accelerated toward the center, but it never reaches the center because it is also moving around the circle. The tension in the string provides centripetal acceleration. Gravity provides the same thing for the moon. Earth's pull is the invisible string, constantly tugging, constantly curving the moon's path, but never drawing it closer, because the moon's sideways motion exactly compensates. The ball on a string and the moon in orbit are mechanically identical. The only difference is that gravity does not require a physical tether. Gravity reaches across void. Gravity pulls without touching. Gravity holds the moon in its endless fall without any visible connection at all. Now here is something that might disturb you further. If the moon is falling toward Earth, then by my own third law of motion, Earth must also be falling toward the moon. For every action, there is an equal and opposite reaction. The moon pulls on Earth with exactly the same force that Earth pulls on the moon. The difference is that Earth is 81 times more massive than the moon, so Earth accelerates 81 times less, while the moon falls 1.4 millimeters per second toward Earth. Earth falls about 0.017 millimeters per second toward the moon. Both bodies orbit a common center, a point called the barycenter, located about 1,000 miles beneath Earth's surface. The moon does not simply circle a stationary Earth. The moon and Earth circle each other, dancing around their shared balance point, both falling toward each other, both missing, both tracing out their respective paths around that invisible pivot. You are falling toward the moon right now. The entire Earth is falling toward the moon, and the moon is falling toward you. This mutual falling, this cosmic dance of perpetual near collision, produces the stable orbital configuration that has persisted for billions of years and will continue for billions more. I want to return to that number, 1.4 millimeters per second. Remember it. Let it sit in your mind, because that number is not arbitrary. That number emerges directly from the inverse square law applied across lunar distance, and that number allows me to demonstrate the most beautiful verification of my theory. Watch this logic carefully. At Earth's surface, objects fall with an acceleration of roughly 10 meters per second per second. The moon is 60 Earth radii away. If gravity weakens with the square of distance, then at the moon's location, gravity should be 10 divided by 60 squared, which is 10 divided by 3,600, which is approximately 0.0028 meters per second per second. That is the acceleration the moon experiences toward Earth. Now, how far does an object fall in 1 second if it accelerates at that rate? The formula for distance fallen under constant acceleration is 1/2 times acceleration times time squared. Plugging in the numbers, 1/2 times 0.0028 times 1 squared equals 0.0014 meters. That is 1.4 millimeters, exactly what we observe. The moon's orbital behavior matches precisely what you would expect if an apple's gravity extended to the heavens, weakening with distance squared, still present even 240,000 miles away, still bending the moon's path, still enforcing the same laws that govern every falling stone. This is not coincidence. This is not approximate agreement. This is precise, quantitative confirmation that celestial mechanics and terrestrial mechanics are unified. The moon obeys the same physics as an apple. The planets obey the same physics as cannonballs. The universe is not divided into earthly and heavenly realms with separate rules. There is one physics, one set of laws, operating everywhere at all times. And I found that unity by asking why the moon does not fall down. The answer, as you now understand, is that the moon does fall down. It just keeps missing. Let me pause here and address a question you might be forming. If the moon is falling toward Earth, why does it not speed up? When you drop a stone, the stone accelerates, gains velocity, moves faster and faster as it falls. Why does the moon not do the same? Why does the moon maintain a roughly constant orbital speed instead of continuously accelerating until it crashes? This is a crucial point. The stone accelerates because it is falling in the same direction it is moving. Downward motion plus downward acceleration equals increasing downward speed. But the moon is moving sideways while falling downward. The acceleration is perpendicular to the motion. Perpendicular acceleration does not change speed, it changes direction. Think about that ball on a string again. When you swing it in a circle, the tension pulls inward constantly, but the ball does not speed up or slow down. It just turns. It traces a circle at constant speed because the force is always perpendicular to the velocity. Gravity does the same thing to the moon. It pulls inward while the moon moves sideways. It bends the path without changing the speed. The moon falls in the sense of being continuously deflected toward Earth, but that deflection is always at right angles to the motion, so no speeding up occurs. The fall is real. The acceleration is real, but the acceleration alters direction, not magnitude. This is why the moon orbits at a stable velocity for billions of years without spiraling in or flying away. The falling changes the path, but not the pace. Do you see now why orbit was so hard to understand before I worked this out? The ancient astronomers knew the moon circled Earth. They tracked its motion, predicted eclipses, calculated its position with impressive precision. But they did not know why it circled. They imagined crystal spheres carrying celestial bodies through their appointed courses. They imagined angels pushing planets along their paths. They imagined inherent circular motion that celestial objects naturally possessed. What they could not imagine was falling, because falling meant downward. Falling meant approaching the ground. Falling meant impact and destruction. How could something fall forever? How could falling produce circles? The answer required a shift in thinking. Falling is not about moving downward. Falling is about accelerating toward a center. And if you combine that acceleration with sideways motion, the falling curves into orbit. The moon is not moving in a circle because circles are natural or divine or built into the fabric of celestial reality. The moon moves in a circle because the geometry of continuous falling plus sideways velocity produces circular paths. There is nothing special about circles. They emerge from simple physics applied over empty space. I mentioned earlier that my discovery triggered an avalanche. Let me show you one branch of that avalanche that might surprise you. I proved that any two objects with mass attract each other. Earth pulls the moon pulls Earth, the sun pulls all the planets pull each other. This mutual attraction produces not just simple orbits, but complex perturbations. Jupiter's gravity tugs on Saturn as they orbit the Sun. Saturn's orbit is not a perfect ellipse because Jupiter keeps nudging it. Mars pulls on Earth. Earth pulls on Mars. The solar system is not a collection of independent orbits, but a web of mutual influences, each body affecting every other. The whole system evolving according to their combined gravitational interactions. This complexity meant that predicting planetary positions required accounting for all these perturbations. It meant that the mathematics of celestial mechanics became extraordinarily intricate. It meant that astronomers could use observed perturbations to deduce the existence of unseen objects. In the 1800s, astronomers noticed that Uranus was not quite following its predicted orbit. Something was pulling it off course. Using my laws of gravity, they calculated where an undiscovered planet must be to produce those perturbations. They pointed their telescopes at that location, and there was Neptune. They discovered a planet with mathematics before anyone ever saw it with eyes. My equations reached across the solar system and revealed hidden worlds. That is the power of universal gravitation. That is what flows from understanding that the moon falls 1.4 millimeters per second. The same logic allowed scientists to calculate the masses of distant objects. If you know how fast a moon orbits its planet and how far away it orbits, you can calculate the planet's mass. Gravity's strength depends on mass. Orbital speed and distance depend on gravity. Work the equations backward, and the planet's mass emerges. We know Jupiter's mass not because anyone weighed it, but because we watched its moons circle and applied my mathematics. We know the sun's mass not because we sent a scale to the corona, but because we measured Earth's orbital distance and velocity and calculated what central mass could produce such an orbit. Every mass in the solar system, every mass in the galaxy, has been determined through the consequences of falling. Objects fall toward each other. That falling reveals mass. My insight about the moon unlocked the cosmic census. Let me tell you about another branch of the avalanche. Tides. I mentioned them earlier, but they deserve deeper examination. You live on a planet whose oceans rise and fall twice daily. Civilizations have watched this phenomenon for millennia. Fishermen learn the patterns. Navigators time their arrivals by the tides. But nobody knew why the waters moved. What force could lift entire oceans and then set them down again with such regularity? The answer is falling. The moon pulls on Earth's oceans. The water nearest the moon falls toward it slightly more than the water on Earth's far side. This differential pull creates a bulge of water facing the moon. But here is the part that surprises most people. There is also a bulge on the opposite side of Earth, directly away from the moon. Why? Because the solid Earth is pulled toward the moon more strongly than the far side water. The Earth falls toward the moon slightly, leaving the far side water behind. The net result is two bulges, one facing the moon and one facing away. As Earth rotates beneath these bulges, coastlines experience 2 high tides per day. The moon causes tides by falling toward Earth and by making Earth fall toward the moon. Differential falling across an extended body produces tidal forces, and those same tidal forces, acting over billions of years, have slowed Earth's rotation and pushed the moon gradually outward. The day used to be shorter. The moon used to be closer. Tidal friction has transformed both. The falling that creates orbits also reshapes worlds over cosmic time. Every discovery leads to another. Every answer generates new questions. This is the avalanche I speak of. One insight triggers a cascade that has not stopped in 3 centuries. I understood falling. That understanding revealed universal gravitation. Universal gravitation explained orbits. Orbital mechanics predicted undiscovered planets. Tidal analysis showed how angular momentum transfers between bodies. Perturbation theory mapped the web of gravitational influences. Escape velocity calculations showed how fast you must throw something to break free of a planet's pull. Black hole physics emerged when scientists asked what happens if gravity becomes strong enough that even light cannot escape. General relativity reframed everything by revealing that gravity is geometry, not force. And still the avalanche continues. Gravitational waves, ripples in spacetime predicted by Einstein and finally detected in 2015, opened a new way to observe the universe. Those waves are created when massive objects fall toward each other so violently that they shake the fabric of space itself. Colliding black holes, merging neutron stars, falling taken to its ultimate extreme. All of it traces back to the simple observation that the moon does not float. The moon falls, everything falls, and the mathematics of falling unlocks the machinery of the cosmos. I am not finished with you, not even close. You have learned that the moon falls. You have learned that orbit is perpetual falling without landing. But I do not think you have truly felt how strange this is, how unsettling it should be, how completely it overturns everything humans believed for thousands of years about the nature of the heavens. Let me push you further. Let me make you uncomfortable with what you now know. Before I came along, learned men believed the heavens were perfect, incorruptible, unchanging, eternal. The celestial realm operated according to principles entirely separate from the messy, decaying, fallen world beneath. Aristotle taught that celestial bodies moved in perfect circles, because circles are perfect shapes, because the heavens were made of a perfect fifth element that knew no change. Objects on earth moved and then stopped, seeking their natural places. Objects in the sky moved forever in perfect circles, requiring no explanation beyond their inherent perfection. Objects on earth were made of four elements that sought their natural places. Objects in the sky were made of a fifth element, quintessence, that knew no corruption. The division between terrestrial and celestial was not merely a scientific assumption. It was theological. It was philosophical. It was woven into the very fabric of how humans understood their place in creation. The heavens were divine. The earth was base, and the two could not possibly operate according to the same rules. I demolished that wall. I took the falling apple and extended it to the moon and proved that the same crude, earthly force that pulls fruit from trees also steers the luminaries of heaven. The moon is not divine. The moon is a rock, subject to the same physics as any pebble you kick along a road. The planets are not angels or ethereal intelligences tracing perfect geometric patterns. The planets are masses of matter, tugged and pulled by the same gravity that makes your feet stick to the ground. I did not merely solve a physics problem, I committed cosmological heresy. I dragged the heavens down to earth and showed that there is no up there and down here. There is only here. One universe, one set of laws, one falling that encompasses everything from raindrops to galaxies. Do you feel the weight of that? For thousands of years, humans looked at the sky and saw something fundamentally other, something beyond their reach, something operating in a realm of perfection that their grubby, mortal existence could never touch. And I proved it was all the same stuff. The moon falls like an apple. Jupiter falls around the sun like a cannonball, curves toward the ground. The stars themselves, though I could not measure their motions in my lifetime, must also pull on each other, must also fall toward each other, must also obey the same universal law. Nothing is exempt, nothing is special, nothing floats serenely above the physics that governs your daily life. You live in a universe where everything falls toward everything else. Always. Everywhere. Without exception. The majesty of the night sky is not divine perfection. It is an incomprehensibly vast collection of falling objects, each one tumbling toward every other. The whole cosmic dance choreographed by nothing more than mass and distance and the geometry of curved paths through void. I want to return to that thought experiment with the cannon, because there is more to extract from it, much more. Imagine again that you stand on an impossibly tall mountain above the atmosphere with a cannon pointed horizontally. You fire. The cannonball flies forward and falls downward simultaneously. It traces a curved path and eventually hits the ground. Now, I told you that if you fire fast enough, the cannonball will curve around the Earth and never land. It will orbit. But what happens if you fire even faster than that? What if you give the cannonball so much sideways velocity that it not only keeps up with Earth's curvature, but actually gains altitude as it goes? Think carefully. If you throw a ball upward, it rises, slows, stops, and falls back. Gravity decelerates it on the way up. But if you throw the ball sideways fast enough, it enters orbit. What happens in between? What happens if you fire the cannonball faster than orbital velocity, but not quite fast enough to escape entirely? The cannonball rises away from Earth, slowing as gravity pulls it back, reaching some maximum distance, then falling back, speeding up, swooping close to Earth, then rising again. It traces an ellipse, a stretched circle, a closed path that carries it sometimes closer, sometimes farther, but always returning. This is what comets do. This is what planets do around the sun. Not perfect circles, but ellipses, with the central body at one focus of the ellipse. My colleague Kepler figured out that planets move in ellipses decades before I explained why. My contribution was showing that elliptical orbits emerge naturally from inverse square gravity. The shape of orbits is not arbitrary. It is mathematically required. Given the force law I discovered, orbits must be conic sections, circles, ellipses, parabolas, or hyperbolas, depending on speed and direction. The falling determines the shape. The shape reveals the falling. Everything connects. Let me dwell on this point because it demonstrates the power of mathematical physics. Kepler discovered empirically that planets move in ellipses. He measured, he calculated, he found the pattern. But he did not know why ellipses. He had no explanation for the shape. I showed that ellipses emerge necessarily from inverse square gravity. If you have a central force that weakens with the square of distance, objects moving under that force must trace conic sections. The mathematics demands it. There is no other possibility. This is the difference between description and explanation. Kepler described the shapes. I explained them. And once you have an explanation, you gain predictive power. You can calculate what will happen in situations never before observed. You can design trajectories to distant planets. You can send spacecraft to exact rendezvous points years in advance. All because the mathematics of falling is understood, not merely catalogued. Now fire the cannon even faster. Give the cannonball so much velocity that gravity cannot curve its path into a closed loop. The cannonball rises away from Earth, slowing as it climbs, but never slowing quite enough to stop and fall back. It escapes. It leaves Earth behind and sails off into the void, never to return. This is escape velocity, the minimum speed required to break free of a gravitational pull permanently. For Earth, that speed is about 11 kilometers per second. Fire something at 11 kilometers per second from Earth's surface, and it will never come back. It will fall toward Earth forever, but its outward motion will always exceed its inward falling, and it will gradually coast away into interplanetary space. Every rocket that has ever left Earth, every probe sent to Mars or Jupiter or beyond the solar system, had to reach escape velocity. They had to be thrown sideways so fast that their perpetual falling could not curve them back. They are still falling toward Earth right now, every one of them. Even the Voyager probes billions of miles away. They will fall toward Earth for eternity, but they are moving away faster than they are falling back. So the falling never catches them. Do you see how falling permeates everything? Even escaping is falling. Even leaving forever is falling. There is no motion in the universe that is not inflected by falling towards something. Let me give you another thought experiment. This one will disturb you in a different way. Imagine you are in a sealed box with no windows. You feel your feet pressing against the floor. You feel weight. You drop a ball and it falls to the floor. Everything behaves normally. Now, is the box sitting on Earth's surface, held up by the ground, with gravity pulling you downward? Or is the box in deep space, far from any planet or star, being accelerated upward by a rocket's engine at exactly the rate that gravity would pull you on Earth? Think about this. If a rocket accelerates the box upward at 10 meters per second, you would feel pressed against the floor. You would feel weight. You would drop a ball and it would fall to the floor. From inside the box, you could not tell the difference. Gravity pulling you down feels identical to acceleration, pushing the floor up into you. This equivalence is not approximate, it is exact. There is no experiment you can perform inside the sealed box that would distinguish between gravity and acceleration. This troubled me. I noticed it, but could not explain it. Why should these two completely different physical situations produce identical experiences? Let me make this even clearer. If you drop a ball in the box on Earth's surface, it falls to the floor. If you drop a ball in the accelerating box in deep space, it also falls to the floor. Not because gravity pulls it, but because the floor accelerates upward to meet it. From the ball's perspective, from your perspective inside the box, the two cases are indistinguishable. Now extend this further. If you shine a beam of light horizontally across the box, in the accelerating case, the floor rises while the light travels, so the light hits the far wall slightly lower than where it started. The light appears to bend downward, but if the accelerating box cannot be distinguished from the gravitating box, then light must also bend in a gravitational field. Gravity must affect light, but light has no mass. How can gravity pull on something with no mass? This is exactly the kind of question my work raised, but could not answer. 2 centuries later, Einstein would make this equivalence the foundation of general relativity. He would show that gravity and acceleration are indistinguishable because they are the same thing. Mass curves spacetime. Objects in that curved spacetime feel what we call gravity, but an object in freefall feels nothing at all. An astronaut falling in orbit is weightless precisely because falling is the natural state. It is standing still on Earth's surface that requires explanation. The ground pushes up against your feet, preventing you from falling, and you interpret that push as weight. You are not being pulled down, you are being pushed up. And if the ground vanished, you would fall freely, feel no weight, and follow the natural curved path through spacetime. But I am reaching beyond my own work now. The point is this. My discoveries opened questions I could not answer. Questions that required new physics, new mathematics, new ways of thinking about space and time themselves. The avalanche I started did not stop with me. It crashed onward through centuries. Let me return to the moon and add another layer to your understanding. I told you the moon falls 1.4 millimeters per second toward Earth. I told you this tiny fall, compounded continuously, curves the moon's path into an orbit. But I have not told you what this reveals about time, about duration, about how long a second really is in cosmic terms. Think about what it means for the moon to fall 1.4 millimeters in 1 second. That is an absurdly tiny distance, the width of a pinhead. In that same second, light travels nearly 300,000 kilometers. The moon barely nudges downward, while light screams across most of the distance from Earth to moon. This tells you something about the relationship between gravity and scale. Gravity is weak, astonishingly weak. It is by far the weakest of the fundamental forces. Electromagnetism is vastly stronger. The nuclear forces are stronger still. A small magnet can lift a paperclip against the gravitational pull of the entire Earth. Think about that. The whole planet, 6 trillion kilograms of rock and iron and nickel, pulls downward on that paperclip, and a toy magnet overpowers it. Gravity is feeble, yet gravity dominates the universe at large scales. Why? Because gravity only attracts. It never repels. And because it acts between all masses without exception. Electromagnetic forces are stronger, but they come in positive and negative charges that tend to cancel out. A planet is electrically neutral. A star is electrically neutral. So electromagnetism does not reach across astronomical distances with any significant effect. But gravity just adds and adds and adds. Every bit of mass pulls on every other bit of mass. There is no cancellation. There is no shielding. Over cosmic distances, gravity accumulates until it dominates everything. The moon falls 1.4 millimeters per second, not because gravity is strong, but because even weak gravity, acting on massive bodies over vast distances through billions of years, produces the grand motions of the cosmos. Patience and ubiquity compensate for feebleness. This should shift your perspective on power, on influence, on how things get done in the universe. The flashy forces, the strong forces, the forces that rip atoms apart and bind nuclei together, operate only at tiny scales. They burn out over distances smaller than a grain of sand. Gravity, the weakest force, the force you can overcome by jumping, operates at every scale without limit. It reaches across billions of light years. It pulls on galaxies at the far edge of the observable universe. The moon falls toward Earth because every particle in the moon feels every particle in the Earth pulling on it. The effect summed across trillions upon trillions of atoms, producing a net pull that curves a path through space. The weak, accumulated, patient, inexorable force wins. There is a lesson here beyond physics, but I will let you draw it yourself. Consider what this means for the structure of the cosmos. Galaxies do not fly apart because gravity, weak as it is, reaches across hundreds of thousands of light years and holds billions of stars in collective orbits around a common center. Galaxy clusters do not disperse because gravity extends further still, binding hundreds of galaxies into gravitationally coherent structures spanning millions of light years. The observable universe itself has large-scale structure, filaments, and voids and walls of galaxies, all sculpted by the patient accumulation of gravitational attraction, operating since the first moments after the Big Bang. The feeblest force shaped everything you can see. 1.4 millimeters per second, scaled up across cosmic masses and cosmic distances and cosmic time, built galaxies, built clusters, built the web of matter that stretches across the observable universe. Never underestimate weakness. that never stops. Now I must tell you about the deepest strangeness, the thing I struggled with most, the thing that still, even with all we have learned, contains mystery. How does the Earth know the moon is there? How does the moon know the Earth is there? When I wrote my equations, I described gravity as a force acting instantaneously across empty space. Earth pulls the moon right now, this instant, across 240,000 miles of void, with no delay, no messenger, no physical connection. The moon responds immediately to Earth's pull. If Earth suddenly doubled in mass, would the moon instantly feel the stronger pull? In my mathematics, yes. The effect would be immediate. But this troubled me. It troubled me deeply. How could something act where it was not present? How could Earth reach across the vacuum and tug on an object it did not touch? Every other force I knew required contact. Push something, and it moves. Pull a rope, and the object on the other end follows. But gravity required no rope. Gravity required no contact. Gravity leapt across empty space and acted on distant objects as if the space between did not exist. I called this action at a distance. I wrote in my Principia that I feigned no hypotheses about the cause of gravity. I described what gravity does with complete precision. I could not describe what gravity is or how it reaches across emptiness. Action at a distance, I called it. The phrase itself admits the mystery. How can one object act on another with nothing between them? For 2 centuries, physicists lived with this mystery. They used my equations. They predicted motions. They sent rockets and found planets and mapped the solar system. But they could not explain the mechanism. Then came Einstein with an answer so strange, it still bends minds today. Gravity is not a force that reaches across space. Gravity is the shape of space. Mass tells space-time how to curve. Curved. Space-time tells mass how to move. There is no action at a distance because there is no distance in the usual sense. The moon moves through a space-time that Earth has warped. The moon follows the straightest possible path through that warped geometry, and that straightest possible path happens to curve around Earth. The moon is not being pulled. The moon is falling freely along a geodesic, a path of least resistance through bent space-time. And the moon does not need to know Earth is there, because the moon is not responding to Earth directly. The moon is responding to the local shape of space, which Earth has curved by its presence. This is why gravity feels different from other forces. This is why falling feels like nothing at all. You are not being pushed or pulled when you fall. You are moving naturally through curved geometry. It is standing on the ground that requires a force, the ground pressing upward against you, deflecting you from your natural freefall path. But here is what I want you to understand. This Einsteinian picture, this curved space-time geometry, does not contradict my mathematics. It explains them. It shows why gravity follows an inverse square law. It shows why gravity affects all masses equally. It shows why falling is different from other kinds of motion. Einstein did not overturn my work. Einstein revealed the deeper foundation and beneath my work. My equations remain valid. My predictions remain accurate. The moon still falls 1.4 millimeters per second, whether you describe that fall as a force pulling it or as curved space-time guiding it. The avalanche continues. Each generation peels back another layer, but the layers do not negate what came before. They illuminate it. Here is something I want you to appreciate. I could not have discovered general relativity. The mathematics did not exist in my time. The concepts did not exist. The experimental evidence, that would demand such a radical revision of space and time had not been gathered. I worked with what I had: geometry, calculus that I invented for this purpose, careful observation of motion. I built a framework that worked, a framework that predicted Neptune before anyone saw it, a framework that enabled humanity to calculate orbits and launch spacecraft and navigate the solar system. Einstein did not prove me wrong. Einstein showed what lies beneath the framework I built, the flaw under my flaw. And someday, someone will show what lies beneath Einstein. The avalanche does not stop. Every answer is a new question. Every foundation is a ceiling for the level below. I want to come back to something practical, something you can feel in your bones. You, sitting or standing, wherever you are right now, are being held away from free fall by whatever surface supports you. The chair pushes up against you. The floor pushes up against you. That push is what you call weight. If the surface vanished, you would fall. You are constantly on the verge of falling, constantly being prevented from your natural state of free fall. Every moment of your life, Earth's gravity tries to make you fall toward its center, and the electromagnetic forces in solid matter push back, keeping you suspended just above the falling. You live your entire life teetering on the edge of an endless drop. The only reason you are not plummeting right now is that atoms are in the way. Take away the atoms and you would tumble toward Earth's center at 10 meters per second, joining the eternal falling that governs everything from moons to galaxies. And here is something that might unsettle you further. You are falling right now, in a different sense. Earth is falling around the sun. You are on Earth. Therefore, you are falling around the sun at roughly 30 kilometers per second. You are sweeping through space in an enormous orbit, constantly falling toward the sun, constantly missing because of your sideways motion. You do not feel this fall because everything around you is falling with you. The air falls with you. The ground falls with you. Your coffee cup falls with you. When everything falls together, there is nothing to feel. Falling is only detectable when something falls differently than you do. In your daily life, the ground falls with you around the sun. So you notice no solar falling, but you do notice terrestrial falling when you trip and the ground suddenly rushes up. That rush is not the ground moving toward you. That is you moving toward the ground. You briefly entering freefall while the ground, held up by the rock beneath it, stays in place. Every stumble, every dropped object, every rolling ball is a tiny encounter with the same physics that keeps the moon in orbit and the Earth circling the sun. Think about what this means for your experience of motion. You are hurtling through space at 30 kilometers per second right now, 67,000 miles per hour relative to the sun. You feel nothing. No wind. No acceleration. No sense of velocity at all. This is because velocity is relative. Only changes in velocity, accelerations, produce sensations, and your 30 kilometers per second orbital velocity is constant. It changes direction continuously as Earth curves around the sun. But the magnitude stays roughly the same, and the change in direction is so gradual that you cannot perceive it. The Earth falls toward the sun. You fall with it. The falling changes your direction of motion constantly, but so slowly, so smoothly, that your body cannot detect it. You are in free fall around the sun without any awareness of falling. Only by looking at the stars over months and seeing them shift position can you detect Earth's orbital motion. The falling is real. The falling is continuous. The falling is precisely calculable. and the falling is utterly invisible from the inside. But the falling goes deeper still. The sun is falling around the center of the Milky Way galaxy, taking Earth and Moon and all the planets along for the ride. We orbit the galactic center once every 230 million years, circling a supermassive black hole 4 million times the mass of the sun, falling toward it, missing it, sweeping around in a great spiral arm along with hundreds of billions of other stars. And the Milky Way itself is falling toward the Andromeda Galaxy, the two great spirals drawn together by mutual gravity, destined to collide and merge in 4 or 5 billion years. Every scale reveals the same pattern: falling and missing, orbiting, circling, curving through space-time along paths bent by mass. There is no stillness anywhere. There is no rest. There is only falling, and the intricate dance of trajectories that falling produces. This is why I called it universal gravitation, not Earth gravity, not solar gravity, universal gravity. The same law operates between any two masses anywhere in the cosmos. A grain of sand and a galaxy obey identical mathematics. The force between them may be immeasurably small, but it exists. It can be calculated. It follows the same inverse square law. There are no exceptions, no special cases, no realms where gravity takes a holiday. Every mass pulls on every other mass at all times. The universe is a web of gravitational connections so dense that every object is linked to every other object. You are gravitationally connected to stars you will never see, to galaxies billions of light years away, to everything that has mass anywhere in the observable universe. The connections are weak, immeasurably weak at cosmic distances, but they are real. They exist. They can be written as equations. And in principle, if you had perfect knowledge and infinite computing power, you could trace every falling, every tug, every deflection from every mass in the cosmos. Let me tell you what I think is the most profound implication of all this, and I want you to think carefully about it. The moon does not know it is in orbit. The moon experiences only local motion, only its immediate trajectory, only the next instant of its path. From the moon's perspective, it moves in a straight line through empty space. There is no sense of curving, no sense of circling, no sense of falling. The orbit is only visible from outside, from a perspective that can see the whole path at once. The moon traces a circle because space-time is curved, but the moon itself moves straight through that curvature. This means something strange about the universe. The large-scale patterns are invisible from inside. You cannot see your own orbit. You cannot feel your own falling. You experience only the immediate, the local, the next instant. The grand trajectories emerge only when viewed from a vantage point that does not exist for any participant. The universe is full of motions that are real, mathematically precise, physically determinative, and yet completely invisible to those executing them. The moon has been falling for 4.5 billion years without ever knowing it. What are you falling toward without knowing it? I spent my life contemplating these questions. I calculated the motions of comets. I predicted the precession of Earth's axis. I explained why Earth bulges at the equator. I showed how the gravitational tug of the sun and moon on that bulge causes Earth to wobble like a spinning top over 26,000 year cycles. Everything connected to everything else. Each calculation revealed new relationships, new dependencies, new fallings. The universe opened up before me as a vast machine of interconnected motions, all governed by a single principle. all explicable through mathematics, and yet the mechanism remained hidden. I could predict, but not truly explain. I could calculate, but not comprehend. The deepest questions eluded me. Why does mass attract mass? Why does the force follow an inverse square law? Why does gravity exist at all? These questions remain open even today, 3 centuries later. We have better descriptions now. Einstein's curved spacetime is more accurate than my force at a distance, but even Einstein does not explain why mass curves spacetime. Even general relativity takes that as a given, an axiom, a foundation without foundation. The avalanche continues, the questions deepen, and perhaps they will never end. Perhaps physics is an infinite tower, each floor resting on the floor below, with no ground level ever to be reached. I have taken you from a simple misconception, the idea that the moon floats, to a vision of a universe where nothing floats, where everything falls, where orbits are extended, plummets, and stillness is illusion. I have shown you that the same force governing apples governs galaxies. I have shown you that my mathematics, developed in a garden in Lincolnshire 3 centuries ago, reaches from pebbles to black holes and still predicts correctly. I have shown you that the moon falls 1.4 millimeters every second, and that this tiny deflection, summed over time, produces the graceful arc of the lunar orbit. I have shown you that escape requires falling faster than you fall back, that tides arise from differential falling across extended bodies, that the masses of distant worlds can be calculated from watching how other objects fall around them. And I have hinted at mysteries still unfolding, at curved spacetime and gravitational waves and the continuing avalanche of discovery that began when I asked why the moon does not crash into us. But I have not yet given you the final piece, the piece that turns all of this from physics into philosophy, from calculation into wonder. So let me give it to you now. You asked why the moon does not fall down. The answer is that the moon does fall down. Constantly. Forever. The moon has been falling for longer than life has existed on Earth and will continue falling long after humanity is dust. But here is what you missed by asking the question that way. Down is not a direction. Down is a relationship. Down is toward. Down means toward the nearest massive object. For you, standing on Earth, down means toward Earth's center. For the moon, down also means toward Earth's center. The moon is falling down. The moon has always been falling down. You just thought down meant something else. You thought down was an absolute direction, a cosmic orientation, a fixed feature of space. It is not. Down is whatever direction gravity pulls, and gravity pulls toward mass. So down is always toward. The moon falls toward, Earth falls toward the sun. The sun falls toward the galactic center. Everything falls toward something. There is no universal down, only local downs, countless downs, a different down for every object in the universe, each one falling toward its own nearest or largest mass. The universe is not a stage with an absolute floor. The universe is a web of fallings, each object tumbling toward others, the whole structure held in intricate balance by sideways motions that prevent collapse. You live in a universe with no bottom, no floor, no fixed orientation, only mass and distance and the endless falling of everything toward everything else. That is what I learned from the apple. That is what I encoded in my mathematics. That is what the moon has been demonstrating silently in the night sky since before humans existed to watch it. The moon falls, you fall, Earth falls, the sun falls, the galaxies fall, and because everything falls, and nothing stops falling, and the sideways motions exactly balance the toward motions, the universe coheres. The universe holds together not because anything is fixed in place, but because everything is falling and missing in precisely orchestrated trajectories. Stability emerges from motion. Stillness is illusion. Permanence is patterns of falling that persist. Your world, your solar system, your galaxy, your observable universe is a dance of falling objects that have been falling since time began and will fall until time ends. You looked at the moon and saw something floating in the heavens. You saw stillness. You saw suspension. You saw a celestial object hanging in the dark. I look at the moon and see falling. I see 1.4 millimeters per second of continuous descent. I see the same force that tugs apples from trees, reaching across 250,000 miles of void. I see the unity of physics, the universality of law, the great equalizer that governs pebbles and planets without distinction. I see the avalanche of understanding that began with one question and has not stopped cascading for 300 years. The moon is not floating, the moon is falling. And now you know what that means. Now you understand that orbit is not suspension, but perpetual descent. Now you understand that the heavens and the earth obey one physics. Now you understand that gravity reaches everywhere, diminishing with distance, but never vanishing, curving paths and raising tides and binding galaxies. Now you understand that even escape is falling, that even weightlessness is falling, that your entire life unfolds while you fall around the sun without feeling it. Go outside tonight, look up at the moon, and see what I saw 300 years ago. See the falling. See the geometry of perpetual descent. See the 1.4 millimeters per second that has been accumulating since the moon's formation, curving its path, holding it close, making it circle instead of flee. See the same force that governs your feet on the floor, governing that pale disk in the darkness. And remember what this costs to understand. Remember that for millennia, humans saw that moon and wondered. They made up stories. They worshipped it as a god. They tracked its phases to plant crops and schedule festivals. They watched eclipses with terror and awe. They never knew what they were seeing. They never asked the right question. The moon was a mystery hanging in the sky, beautiful and unexplained, beyond the reach of human understanding. Then one plague year, isolated in a countryside garden, I asked why the moon does not fall. And the question unravelled everything. The mystery became mechanics. The god became a rock. The inexplicable became equations. I did not remove the wonder. I transformed the wonder. The moon is more marvellous now than it ever was as an object of worship, because now we understand how marvellous it truly is. Now we see the precision. Now we see the balance. Now we see the 4.5 billion year fall that has never ended and never will. The moon is falling toward you right now. It has been falling toward you for 4.5 billion years. It will never arrive. That is orbit. That is gravity. That is the universe. And you thought it was just floating there.